So in this video, you need to be able to simplify radicals with different nth roots. You need to be able to evaluate expressions with rational exponents. And you need to be able to rewrite a radical with a rational exponent. So looking at the diagram here, you have your n on the outside. N is called the index, or you could also call it the root. The x out here is called the radicand. Anything that's under the radical will be called the radicand. And of course you have just the radical symbol itself. When simplifying radicals, the first thing you need to do is break down the radicand into prime factors. Prime factors 2, 3, 5, 7, back when you were doing factoring trees. The next thing you'll do is bring out groups by the number of the root. So if you have the example 25x squared, you will simplify this based off the root. Well, right now there's nothing on the outside. Well, it's always to be understood to be a 2. So if there is not a number there, it's always understood to be a 2. But if it's a 3, there will be a 3 there, 4, 5, continue from there. And so you will simplify the radicand based off the root 2. So if I were to simplify this based off the root being 2, you can treat it like two different things. What's the square root of 25? And then what would the square root of x squared be? Well, the square root of 25 would be 5. The square root of x squared would be x. The reason why is because if there's two x's underneath the radical and the root's 2, there's only one group of x. So the answer would be 5x. So our first example is a root of 3. And under our radical, we have 128. So what we're going to have to do is break down 128 into prime factors. So what two numbers multiply to give you 128? You can start out with just 2 and 64. 64 breaks down into 2 and 32. 32 breaks down into 2 and 16. 16 breaks down into 2 and 8. 8 breaks down into 2 and 4. 4 breaks down into 2 and 2. I did it this way just so we can have all our 2's lined up, all our prime 2's lined up nicely. Okay, so that's 7 2's. So that's saying 2 to the 7th gives me 128. So what you can do now is rewrite and show that there's 7 2's. So by rewriting 7 2's under the radical, those 7 2's here is another way of writing 128, except that we broke them down in prime factors. So now we got to simplify this radical. Well, now we'll simplify it by grouping them by the index number, which is 3 out here. So we'll circle 3 2's, another 3 2's. Okay, and so we have two groups of 2. So we have 4 on the outside of the radical, because since we had two groups, a 2 and a 2 come out to multiply to give you 4, and then what does not get circled, which is a single 2, stays inside. And so this is our final answer. You cannot put this in the calculator and expect to get this result here. You're going to have to break it down, whether you do it by a factoring tree like you see here, or if you just start with one prime factor like 2 and ask yourself, is 2 to some power give me 128, or does 2 to some power give me 64? Yes, that does work. And so then you'll just rewrite the 2's under the radical and find your groups and then simplify from there. The next one has variables under there, and our root is still 3, so still same thing. So we got 27, break down 27. So we have 3 times 9 gives you 27. And 9 breaks down to 3 and 3. Okay, so I'm going to rewrite what's under the radical. So we have 3 3's. And I'm going to rewrite the x's to be x times x times x. So this time, like I said, we're going to be simplifying and grouping them by the groups of 3. Everything gets circled, 3 of everything. So there's one group of 3, one group of x. As you see, there's nothing that's left over. So everything comes out of the radical. The answer is 3x. Alright, so 32x to the 7 with a root of 4. So 32 we'll break down into, I'll just start with 2, so just say 2 and 16. 16 is 2 and 8. 8 is 2 and 4. And then 2 and 2. So again, you can start, instead of, making this factoring tree, whatever is easier for you, start with 2. Is 2 to some power give me 32? Yes. 5. 2 to the 5th gives you 32. So you know there's going to be 5 2's without having to, write down the whole factoring tree. So we have our 4, our root of 4. So 5 2's. And then there are 7 x's. Okay. So now we'll circle. Now we're going to circle 4 for everything. Okay, we have one group of 2 and one group of x. So all our groups come out of the radical. So we have 2x, but what does not get circled, which is the other 2 and the 3 x's, will stay inside. So 2x with the root of 4, 2x to the third on the inside. And this is our final answer. Okay, so same idea. Root is 3. And this next example, except now we have 9 x's up in the numerator of our fraction and 27 in the bottom. Well, we've already looked at this once before. Okay, so there are 9 x's. Okay, and so we already broke down 27 or, a couple examples ago, so it's going to be 3 times 3 times 3. Well, again, most of you probably recognize, okay, well, 9, 3, there's already going to be 3 groups of 9, because obviously 3 times 3 gives you 9, and then one group of 3, so everything will be coming out of the radical. So we'll have x to the third, because there's 3 groups of x's, all over 3, with one group of 3. Nothing's left in the radical, so it stays just like this as our final answer.